Chapter 6, Matter, Properties, and Phases. Matter and Atoms. Matter describes everything that we can see, touch, smell, or feel. In other words, matter is anything that has mass and takes up space, including air and almost everything else. Matter is anything that has mass and takes up space. The smallest unit of matter is called an atom. An atom is the smallest unit of matter. If you chop a piece of metal into a bajillion pieces, the smallest bit you are left with that still has the properties of metal is called an atom. The word atom is derived from a Greek word that means cannot be divided, and the Greeks didn't even have a particle accelerator. Atomic models. Remember that a model is a way to represent something that we can't easily see. Atoms are made of smaller particles. Protons, positively charged particles. Neutrons, electrically neutral particles, which means they have no charge. Electrons, negatively charged particles with almost no mass. The nucleus is the center of the atom, formed by protons and neutrons. Protons and neutrons stick together to form the center of an atom called the nucleus, which has a net positive charge. Electrons orbit or circle around the nucleus, but too quickly to pinpoint their exact locations. The modern atomic model shows an electron cloud rather than individual electrons like the model above. It demonstrates where you're most likely to find an orbiting electron. Denser areas of the cloud mean a higher probability of electrons. Brief history of the atomic models. John Dalton was the first scientist to propose that elements are composed of indestructible atoms. He thought that there were particles so small that we could not see them. He called these particles atoms, and his theory on matter was known as the atomic theory of matter. Sir Joseph John, or J.J. Thomson, discovered the presence of negatively charged particles, electrons, in atoms and pictured them embedded with positively charged particles, kind of like raisins in oatmeal raisin cookies. Ernest Rutherford worked out that each atom had a small and a heavy positively charged center, which he called a nucleus. He figured out that electrons were orbiting the nucleus in mostly empty space. He called the positive particles in the nucleus protons. Rutherford's student Sir James Chadwick proposed the existence of uncharged particles in the nucleus, which he called neutrons. Physical and chemical properties and changes. The way something looks, feels, smells, and tastes are all physical properties. It's easy to classify matter by these characteristics. Some common physical properties used to differentiate matter are color, size, density, malleability, which is how easily something can be flattened, shaped, or pressed, magnetism, whether or not something is magnetic, boiling point and melting point, the temperature at which something boils or melts, solubility, how easily something dissolves in another substance. A physical change is any change to the physical properties of matter, such as its size, shape, or state, solid, liquid, or gas, or vapor. The final product of any physical change is still composed of the same matter. For example, you can revert ice, snow, or vapor back to water by either heating or cooling it. Ice, vapor, and water are all the same matter, just in different states. Chemical properties describe the ability of something to undergo different chemical changes. Some examples of chemical properties: flammability, how easy something lights on fire; reactivity, how reactive something is to oxygen, water, light, etc. When any of these chemical properties change, the matter has gone through a chemical change. Rust on an iron gate or a log burning and producing ashes are both examples of chemical changes. Chemical changes are when matter changes into new substances with new properties. Some signs of chemical change may include change in color. This is like when you leave a sliced apple out and it turns brown. Change in energy. The chemicals react, releasing energy in the form of bright lights and heat. Think of fireworks. Change in odor. Think of food going rotten. Formation of a gas or solid. When you add two substances together, such as vinegar and baking soda, you frequently see bubbles. Bubbles, or gas formation, are a sign that the ingredients have undergone a chemical change. Chemical changes are often much harder to reverse than physical ones. Just imagine trying to turn ashes back into a log of wood. Synthetic materials are materials that don't occur in nature, but are instead made from natural resources that undergo a chemical change. For example, polyester is a synthetic fiber made from air, water, coal, and petroleum. Acid and alcohol are used to create a chemical reaction, which results in polyester fibers. Conservation of mass. While things may change appearance or composition during physical and chemical changes, one thing remains constant: the amount of matter present. This concept is called the conservation of mass. So mass doesn't just disappear, it still exists, but it may be in a different form, like in the surrounding gases. The atoms have just rearranged to form different substances. Conservation of mass is the amount of mass at the start of a reaction will equal the amount of mass after the reaction. A reactant is a substance that is changed in a physical or chemical reaction, and the product is the resulting substance of a physical or chemical reaction. The reactant is equal in mass to the product. States of matter. Matter is usually found in 3 states or phases: solid, liquid, and vapor or gas. The arrangement and behavior of particles is what determines the state of matter. The attraction between particles keeps particles close together, and the energy of their movement allows particles to overcome these attractive forces. A solid, like ice, wood, or metal, is a matter that has a defined shape and volume. The particles in matter are packed closely together, and they don't move around freely, which is why a solid has a defined shape and volume. Still, particles in a solid vibrate back and forth, but not enough to overcome the attractive force between particles. Liquids are free-flowing and assume the shape of the container that holds them. Liquids, however, do have a fixed volume. Particles in liquid move around fast enough to overcome attractive forces. While the liquid particles do move freely, they still stick together. The speed at which a liquid flows depends on its viscosity. Viscosity is the resistance to flow. Vapors, or gases, don't have fixed volume or shape. The shape and volume of a gas depends on its container, and unlike liquids, it will fill any container you place it in. The molecules in gas spread really far apart and move at high speeds. Gas molecules move so quickly that they are able to overcome attractive forces between particles, which allows the molecules to separate on their own. If you spilled the gas from a balloon into the air, it would disperse evenly into the air. State, solid, features fixed shape and volume. Movement of particles vibrate but have fixed positions. Liquid, shape can change, but volume is fixed and it can flow. It's free moving and there's no fixed positions for the particles. Gas, shape and volume are not fixed and it depends on the container. It can flow. And the particles move quickly and are far apart. Phase changes. A state is not permanent. Changes in pressure and temperature alter matter. These are described as phase changes. Melting is when matter changes from solid to liquid. The melting point is the temperature at which a solid melts. Heat causes solids to melt by increasing the movement of particles. As the particles gain more and more energy from the heat, they move more and more until they no longer are fixed in place. Above 100 degrees Celsius, water is a vapor. Between 0 degrees Celsius and 100 degrees Celsius, water is a liquid. Below 0 degrees Celsius, water is a solid. Freezing is when matter changes from liquid to solid. As liquids cool down, the particles move less and less. At some point, the motion of particles can't overcome the attractive forces between particles, and the liquid turns to solid. The temperature at which a liquid freezes is called the freezing point. Vaporization is when liquid turns to vapor. When sweat disappears and dries up, it has vaporized or evaporated. Evaporation happens slowly and only at the surface. Individual molecules get bumped out into the air. When water boils, it has reached the temperature at which water turns from liquid to vapor. Heat causes liquid particles to move around quickly. When the particles are moving around fast enough to overcome all the attractive forces between particles, the liquid turns to vapor. Condensation is when vapor turns to liquid. When you get a really cold drink, the air around the glass condenses and forms little water droplets on the surface of the glass. When water vapor in the air cools down and loses energy, the particles start to slow down. When the particles slow down enough, the attractive forces between particles cause the molecules in the vapor to stick together, forming a liquid. Sometimes, under extreme conditions, solids can change directly to vapors, which is called sublimation. Dry ice, for example, sublimates when the CO2 ice turns directly into CO2 vapor. Vapors sometimes change directly into solids, which is called deposition, like when frost appears on grass overnight.